So, welcome back, friends. Yesterday, we concluded a few sums from this parametric differentiation. And I said that there is a sum which is very, very important and which we have to learn very carefully. That sum, now I would like to take up, and then we will close this parametric differentiation and go to the next concept. Let us go to the whiteboard. So, parametric differentiation, you know very well that it will be containing two equations, one with a y, another with a x, like that. So let us start the sum. Find dy by dx given x is equal to sine cube t divided by root of cos 2t, and y is equal to cos cube t divided by root of cos 2t. Okay, so this is a little bit long sum, but let us start doing this. So first, x is equal to sine cube t divided by root of cos 2t. We are supposed to find out dx by dt. Dx by dt is equal to, this is in the form of u by v. U by v means quotient form. Quotient rule we should understand or remember. What is quotient rule? U by v differentiation. V into denominator into differentiation of numerator minus numerator into differentiation of denominator divided by denominator square. So this formula will apply in this. Root of cos 2t into d by dt of sine cube t minus sine cube t into d by dt of root of cos 2t whole thing divided by root of cos 2t whole square. So this formula as it is we applied denominator into differentiation of numerator minus numerator into differentiation of denominator divided by denominator whole square. So root of cos 2t d by dt of a sine cube t, apply the power rule. 3 into sine square t sine t differentiation cos t minus this function sine cube t into d by dt of root of cos 2t. Root of cos 2t differentiation 1 by 2 root cos 2t. Cos 2t differentiation minus sine 2t. 2t differentiation 2. So here we have applied this formula. What is that formula? D by dx of root x. That is 1 by 2 root x. So in the place of root x, we are having a root cos 2t. That differentiation 1 by 2 root cos 2t. Chain rule. Cos 2t differentiation minus sin 2t. 2t differentiation 2. This entire thing divided by root of cos 2t whole square will become cos 2t. Here, these 2 and these 2 cancel. Now you multiply root of cos 2t LCM we are doing in the numerator side. So that will become root cos 2t into root cos 2t will become cos of 2t. This 3 as it is. Sin square t cos t minus into minus plus into sin cube t into sin 2t. This you write it as 2 sin t cos t. Entire thing divided by this root of cos 2t will come and multiply this denominator cos 2t So cos 2t into root of cos 2t. Okay, you are following now? So first we have started with x. So here what you are having sin square t cos t. Here sin t is there, sin cube t is there, cos t is there. So sin square t cos t you can take out common. If you take out sin square t cos t in the numerator, you are left with 3 cos 2t here. And here what you will be left with 2 sin square t cos t. 2 sin square t cos t. Okay. So we are having here sin square t cos t common. Go to the previous page again and check up. Sin square t cos t common. 3 cos 2t. First we'll go that. 3 cos 2t plus. What is other end now? Other side you are having 2 sin t cos t. That is total sin fourth t will come. Out of this, sin square t cos t going out. Sin square t cos t. So we are left with here 2 sin square t. 2 sin square t. To sin square t. Whole thing divided by, we are having cos 2t whole to the power of 3 over 2. So now this becomes sin square t cos t do not disturb. 3 cos 2t. This you can write as 1 minus 2 sin square t plus 2 sin square t as it is. Entire thing divided by cos 2t whole to the power of 3 over 2. So this will become now sin square t cos t, open the bracket, 2 minus 4 sin square t. Okay. Here this is 3 I think. 3 cos 2t. So 3 minus 6. This will become what? 6. 3 minus 6 sin square t plus 2 sin square t whole thing divided by cos 2t whole to the power of 3 by 2. So this will become now sin square t cos t bracket 3 minus 4 sin square t divided by cos 2t whole to the power of 3 by 2. Okay. So sin square t cos t, the 3 minus, correct. Now what we do, we send one sin t inside, multiply only one sin t inside. So this will become sin t cos t, open the bracket, 3 sin t minus 4 sin cube t divided by cos 2t whole to the power of 3 by 2. Our idea is what? Nothing. We wanted to write this as sin 3t. That's all. So sin t cos t sin 3t divided by cos 2t whole to the power of 3 by 2. So this is called our first one. First equation we call. This is our dx by dt. Now we will go to the dy by dt. So what is our y now? Y is equal to cos cube t divided by root of cos 2t dy by dt. Procedure is same. So denominator into differentiation of numerator minus numerator into differentiation of denominator, whole thing divided by denominator whole square. So this becomes root of cos 2t First for the power 3 cos square t. Next for the cos t. Cos t differentiation minus sin t. Here cos cube t into 1 by 2 root cos 2t. Cos 2t differentiation minus sin 2t. 2t differentiation 2. Whole thing divided by cos 2t. Because root of cos 2t whole square cos 2t. This 2 and this 2 will go away. So again, by finding the LCM, root of cos 2t into root of cos 2t will become cos 2t. This minus you write in the beginning. 3 cos square t sin t minus into minus plus cos cube t sin 2t will become 2 sin t cos t. Whole thing divided by this root cos t will come in the denominator. So that will become totally whole to the power of 3 by 2. Okay. Now here we will take out common. Cos square t sin t will take out common. First one minus 3 cos 2t. Here what did we take out? Cos square t sin t. So cos square t sin t means here one more cos square t will remain. Okay. 2 is also there here, remember. This 2 will be here. Cos square t will remain. Whole thing divided by denominator. Cos 2t whole to the power of 3 by 2. Okay, now you understood, no? Cos square t sin t. Now this cos 2t we have to write in terms of 2 cos square t minus 1. So step by step we'll go. First cos square t sin t. Open the bracket. Go to the page. What are we having? Minus 3 cos 2t. So minus 3, open the bracket. What we write here? 2 cos square t minus 1. Cos 2t another formula. 2 cos square t minus 1. Then next what we are having? Plus 2 cos square t is there here. Plus 2 cos square t. So whole thing divided by cos 2t whole to the power of 3 by 2. So then what we do? We repeat same step, but we multiply with minus sign. Minus 6 cos square t plus 3 plus 2 cos square t whole thing divided by cos 2t whole to the power of 3 over 2. So here once more we'll repeat cos square t sin t. Please remember this is all actually what? Dy by dt. Here first 3 write down minus cos 4 cos square t whole thing divided by cos 2t whole to the power of 3 by 2. So now you send cos inside. If you send inside, what will happen? Here cos t sin t will remain 3 cos t minus 4 cos cube t whole thing divided by cos 2t whole to the power of 3 by 2. So cos 3t formula we are knowing 4 cos cube t minus 3 cos t. But here you are having ulta. So minus you put inside. So that will become cos t sin t. This will become minus cos 3t. Whole thing divided by cos 2t whole to the power of 3 by 2. Okay. So now this is our second equation. Now we want to find out dy by dx. Dy by dx is equal to equation 2 divided by equation 1. That means dy by dt divided by dy by dx by dt. This is x. So this will become now cos t sin t minus cos 3t divided by cos 2t all to the power of 3 by 2, entire thing divided by sin t cos t sin 3t whole thing divided by cos 2t whole to the power of 3 by 2. So cancel this and this and this and this. So now we are only left with minus cos 3t divided by sin 3t, which is nothing but minus cot 3t. So friends, this is the differentiation dy by dx of x is equal to sin cube t divided by root of cos 2t and y is equal to cos cube t divided by root of cos 2t. So carefully do this sum. It's a very important fundamental sum, and hope with this I'll conclude this parametric differentiation. And now next thing is I'll go to the second degree differentiation. After that we'll go to the applications of differentiation. So thank you. Keep revising the sums.